Welcome, all of you. We have our second guest on stage here today, and it's about how safe are batteries, really, isn't it? Yeah. And we will have on stage here from PowerTech Sweden, Jimmy Henningsson. Give him an applause.
Thank you. A pleasure to see you. Pleasure to see you all here.
And Jimmy, as I heard, I think that this is your first time at Donsu Shipping Meet, is it?
Yes, it is. So it's actually, I really liked the dinner yesterday. It
You
was
did.
amazing.
You were here
Yeah.
yesterday as
Yeah.
well. Yes.
I was here yesterday, just in time for the dinner. Unfortunately.
That's good.
Yeah.
That's really
Yeah,
good.
Free food, you know.
Exactly. And very, very good music and
Yeah.
speeches and things like that. That's good. And today you join us here at on stage.
Yes.
And you are going to talk about how safe batteries are, really.
Yeah.
Are they?
Yeah, I would say so. But I have some headlines in the presentation
Yes.
to see actually to speak about how batteries really are safer or not than the conventional diesel-driven solutions, and how it turns up to be in more or less in the knowledge part of the operators and the installers.
Yes. And you are the founder of PowerTech
Yes.
Sweden.
I
When did you?
10 years ago, give or take a bit.
10 years ago.
And about 2 years ago, basically 2 months before Corona shut down Europe, I sold the company
Oh.
to Örborgen, to Örjan Backman. So
Borjan is here as well.
yeah,
So now I give this. The stage is yours.
thank you, thank you.
Welcome.
And it's always a pleasure to see all you guys here, and also to have my own private cheerleading team here from the whole company. Always good. Rickard, if I pull this off properly, Rickard promised to do the funky chicken dance up here later on. That's good. So I'm going to speak today about how dangerous batteries really are. Because if you look at this way, has the media out there given us a faulty picture how often batteries actually burn if you compare it to other conventional propulsion systems out there? Because when a conventional boat catches fire, there is no such big of a news. But if it would be battery on the boat, the newspaper coverage are 1,000, 100-fold of that. So the question here that I'm going to speak about a little bit, or one of them, is has this given me or us a faulty picture of how batteries actually really behave, and if they are as dangerous as people say or not? So, I'm gonna the magical buttons. So, let's have a look on the statistics just a little bit here. We have on the container ships, we have around 5,500 container ships in the global fleet. We have a fire on them every once a week to every once a second week. That gives us a 0.05% chance of a fire. If you look on the cars side, on conventional cars, we have here in Sweden about 5 million registered cars, 3,700 fires, 0.0% chance. And like you probably noticed, we have down here, 0.01% chance of a fire if it would be a hybrid or electrical car. So that means if you drive a Tesla, it is 1/7 the chance to that catch fire, or if you drive a Volvo. And if you turn that to the news coverage, when I looked at the statistics, I see that, okay, there are 37 fires. But if you look on the newspaper, it sounds like there are hundreds and hundreds of fires every year. Because they are no interesting to write about that the Volvo V70 was fire on E6. No interest. But if a Tesla catches fire on E6, they are news. Then they write about it, and write about it, and write about it. And when somebody writes about it, the next one writes about it. And then it goes on and goes on and goes on. So the question is, has this led us to a faulty pictures? Because these are the pure statistics. But if you look on the newspapers today, it sounds like the hybrid cars would be there and the cars would be there. But that is not actually how it really is. So I would dare to say that the newspapers out there has given us a picture that runs a quite significant risk of not being fully correct. Of course, there are issues with batteries. And it comes down to these agencies. Mainly MSB has helped me with the numbers here. And I asked them, what did they know about fires on ships, boats? And they said, hey, we don't know of anything of them. So the agencies or the governmental are so far lagging behind. So they cannot even tell me if there have been a fire on a hybrid vessel here in Sweden or not. They don't know. They know cars, they know everything else, but not that. Well, I know that there has been a number of incidents here. But the governmental or the agencies out here cannot give us that information. They don't know. But let's run a quick session into the fire thermal runaway, because one thing this happens, and one thing I'm going to speak about a little bit later, is the knowledge part. How do you build a battery system safe? Because it's up to the ship owners and us as system integrators and the knowledge part of the system here to build a system that is safe, to understand it. A shipyard has built hundreds of boats of conventional propulsion. They know how to install a diesel engine. They know how to do it safe. So then they suddenly need to know how a diesel engine works, and then they need to know this part. What causes a fire in a battery system, and how do you prevent it? So a quick recap here. We have two main causes of a cell failure, so-called, in a battery system. We have internal causes, mainly outside the owner's operational control, productions, errors, external penetration, or mainly impurities in the production that causes faulty cells. Or you have the external ones, caused by systems outside the battery system's control. A charger that overcharge, external heating, excess use, basically abuse of the battery. All of these things lead to a temperature increase that leads to an exothermic reaction, and that, somebody way more smarter than me need to explain what that one is. But it is a circle that comes in there, and that happens that a cell goes into fire, and one cell can be this big, not small, not at all. And when that one catches fire, it's no big of a deal, because you have 2, 3, 4, 5 liters of gas, and not so much of a heat, because the energy in that one single cell is not big enough. The problem is when you have propagation. And that is what you read about when you read in the newspaper, again, back to Tesla. That a battery catches fire, you put it out, and then it starts to catch fire again. That means that one cell in the middle here had caused damage to neighboring ones, then they catch on fire and cause damage to a neighboring one. That's propagation. You have a spreading. Earlier that was allowed. Now they're looking on systems that this is not allowed anymore. Earlier it was. And once again, it comes into the knowledge to understand this, and also how to treat it. Because if we look at one of the most famous things out there today, Ytterøyningen in Norway. At the 10th of October 2009, there was a fire in the adjacent, or in the battery room, after some service. And take a note, it was a leaking gasket, so it was not a cell failure or it was an external fault. There's been a service the day before, the gasket was leaking, the water come into the battery, and there you have the issue. But they extinguished the fire in good order. And the boat was able to come back to the shore. And then the day after, there was an explosion in the adjacent switchboard room. And they concluded that that happens because they use saltwater sprinkler. If they used freshwater sprinkler, there wouldn't be an issue. It would have been solved. But they use salt water, and then it comes back to the knowledge part. Then the constructor, the owner, need to know that, okay, with this type of battery, we should not use saltwater sprinkler. And it's up to DNV to have that in their rules and regulations. And it's, in the end, it comes down to this: the people, the money, and the knowledge. The people need to understand what they're doing. They need to understand how a battery system behaves, what infects it, how you should treat it, and how you should do the mitigating issues that you need to handle. Because the people here, or let's say shipyards, let's say a shipyard installed hundreds of diesel motors out there. They know how to do it. They've done it before. They know how to do it. They just do it. And suddenly, you'd expect a shipyard to understand a completely different type of propulsion system that is out there. They need to learn and grasp this on the way. And it's not easy. Because suddenly you don't have anything that says vroom, vroom, like I said out here yesterday. But instead, you have people that it says clunk, a contactor pulls, and then you have all the power. And I've seen so many installations and issues around this where people just simply don't understand how they should install a system, and that makes the system unsafe. The system itself is not unsafe. The battery itself is not unsafe. But you install it in such a way that the mitigating issues that takes care of any risk in the battery are put out of order. Basically because you don't know exactly how to install it. And it's also a money issue. Because if you look here, again, in this one, there are today batteries that has this issue, and there are batteries out there that doesn't have that issue. Any cell can catch fire. You have 3, 4, 5 liters of gas you need to take care of, and then it's not a problem. There are cells out there, today Ecandia is one of them, that has this cell technology, that propagation does not exist. And that brings them that it's a matter of money, it's cost. Because if you run on the money part, you have procurement, the governmental has a procurement out there that tells that the cheapest one are going to win. And then suddenly it shows up there that, okay, the cheapest one, okay, let's see, who's the cheapest? I buy that one from China, that is China Incorporated Battery Unlimited Systems. And then I buy that one from the pop-up company, my local electrical engineer that has installed boats before for me. He does that for cheap. He puts some stuff together. And then you turn on to a cheaper price. And the issue is that even if ship owner one who knows these parts and take care of that internally, he buys a good quality system. And then ship owner two comes in and takes this one from China Unlimited Incorporated Battery Systems. And suddenly, the money wins. And then you have the bigger risk of an unsafe system out there on the boats. And I've seen this. We have boats here in Sweden that runs on old Tesla batteries. That is an approved battery for the governmental part. So a boat that had, or let's say that Tesla did not want to put that battery in the cars. But the Swedish government allowed it to be put in a hybrid vessel for passenger use. And that comes into the knowledge or the rules and regulations out there today. Now the Swedish agency will not allow that, hopefully. But they have. And of course, a cheaper Tesla battery or an old Tesla battery will be cheaper. And then you will win the procurement. And once again, it comes up to the knowledge. But now it's been moved from the ship owners, from the operators, from the installers, to the governmental part, to up here, the agencies. That DNV has rules and regulations to take care of this. That the Swedish agency has rules and regulations they know about. And I'm going to just run one quick example that I've seen out there and that I actually know had caused a fire. That is a typical DC contactor. Because when you think of DC, everyone knows AC. It's not the issue. Every electrical can handle AC. DC is a completely different thing. I've seen people put in AC fuses in DC systems. And, well, basically, they don't work. So I'm going to take one example here. We have the sealed type of contactor. It's small. It's like this, my fist. And this does the job of other type of contactor that is 4 times the size. And it works perfectly if you run it inside the specs. The problem is if you run it outside the specs, well, I tell you like this, it explodes. And one of the main reasons it explodes is not the voltage, it's not the current, it's of inductance. And I can tell you, how many of you knows what inductance is? Yeah, a few. So, but then you know that at the length of a cable that you don't normally on a boat, doesn't even need to think about, don't even need to be care about, can influence that basically your contactor literally blows up. Yes. I have some movies on it later on if you want to see. Because and then you have the open air ones that doesn't have that issue anymore. The issue is, it comes down to the money and knowledge. That one, the DC contactor, the sealed one, is cheaper than the open air ones and significantly smaller. So there you go on that one. So, to run a conclusion, I see that my timer here is running low. So let's have a conclusion. Is it more dangerous to operate an electrical hybrid vessel than a conventional one? I would say yes, if you don't know about the knowledge, if you don't know about these things that makes a battery system completely different to a conventional propulsion one. But if you take care of that one, and you know that one, then it's a no there. Then the battery system itself, in fact and in theory, is safer than a conventional propulsion system. And if you don't trust me on that one, DNV had done the math. This is from a DNV report that's out there. I can give it to you later on if you want. That means that if you put the safeguard in place, you end up here. That's basically 1 in a 200,000 times risk of a fire, or a serious fire, can we say, in a battery room. And that means that, yeah, it is way more risky for you to take the car. There is 100 more times likely for you to get killed in your car on the way to your work than it is for me. So I will more likely be killed in the traffic on my way to work than I will be killed on one of the hybrid boats that we're building. And especially if you smoke, it is more than 1,000 more times that one will kill you than a conventional battery system. I would say that's all for me today. Thank you for listening. And yeah, I think it's question time here, right? Before Rika does the funky chicken dance.
We have a few minutes.
Yeah.
You know that it's your first time at Donsu Shipping Meet.
Yes.
And today it's, 22 is the 7th time we arranged this great meeting. And yesterday we had some news. We had a fishing meet, and then we also had this fire safety meet.
Yeah.
But you didn't join that.
No, I did not. Let's not speak about that.
You came just in time for the evening.
Yeah,
Yes.
the free food.
But
No, but your jokes aside, I missed the ferry.
yes, but you might join the next time.
Definitely.
Definitely, that's good. How can you prepare a possibly fire?
It comes down to the knowledge part.
It does.
Yeah.
Back again to the knowledge.
Back into knowledge. How do you deal with a fire? That, okay, should I have a saltwater sprinkler system or not with this battery? No. Okay, then it's up to me to not install one. Then I can use another type of fire extinguishing system, and then we are safe. We're good. When if, like I normally say, shit happens.
Yes. So
But then it's up to us to know how to take care of it.
yes, and how do we take care of it in the most safety way?
Normally by gas or by fresh water,
Not
not salt water.
salt water.
Yeah. And also to educate the people on the boat to know how to do it. That, okay, you have a sail failure, you have some gas, but you will only have 2, 3, 4, 5 liters of gas. That means that you only need to push it out. You don't need to push every fire emergency button on your board there at the first time. It's enough to let it trigger the gas, trigger the exhaust fans, and then you, in 10 cases, you're almost safe.
So to summary this, the battery itself is safe,
Yeah,
but you have to have the knowledge
yeah,
and the right people
yeah. The right
handling
people.
it,
Yeah,
and not salt water.
yeah.
We have plenty of that here, you know.
Yeah, that's an issue. And you don't want to carry 10,000 of fresh water on a boat because that brings weight.
Thank you so much, Jimmy Henningsson. Your first time at DSM, but I hope to see you next time. This guy is a chief technology manager
Yeah,
at PowerTech Sweden.
exactly.
Thank you so much.